Alright guys, this is a review for your 2-1 test in Algebra 2 for graphing quadratics. Let's get started. Okay, so number 1, it says graphing in parts of the parabola, so we're going to graph this. We're going to use our calculator. Go to your y equals, and I'm going to type my equation. X squared plus 10x plus 16. I'm going to go to my table, and I'm going to find my rainbow. So right away I see -8, -8, -5, -5, 0, 0. So there is my rainbow, and that's what I'm graphing. So -8, 1, 2, 3, 4, 5, 6, 8, 0. -7, -1, 2, 3, 4, 5. -6, -8. -5, -9. Back up the other way. Okay, and there's my graph. Okay. Okay, so right away I see my vertex is in the middle of my rainbow. We should always know that right now. So it's -5, -9. And the y-intercept is where x is 0. So x is 0 at 0, 16. X-intercepts are where y equals 0. So we had both of those on our screen just a second ago. -8, 0, -2, 0. Axis of symmetry is always x equals the x of your vertex. So the x of my vertex is -5. Domain, when there's no situation for parabolas, is always -infinity to infinity with parentheses because it never actually touches infinity. Your range is your height. The lowest this goes is -9, and it goes up forever, so all the way to infinity. And it has a bracket at -9 because it actually has a point at -9. Okay? This doesn't have a maximum point. It has a minimum point at my vertex, -5, -9. Okay? If it opens upwards, it always has a minimum. If it opens downwards, it always has a maximum. Okay, and this 9, your range, will always be the y of your max or min, your vertex or whatever. So let's try this next one. So we have negative parentheses x plus 4 squared plus 1. Second graph, I'm going to find my rainbow. I already see part of it. There we go. So -7, -8. -6, 1, 2, 3, 4, 5, 6. -3, 1, 2, 3. -5, 0. -4, 1. Back down the other side. So my vertex is in the middle, -4, 1. My y-intercept is where x is 0, so 0, -15. X-intercepts are where y is 0, so -5, 0, -3, 0. Axis of symmetry is always the x of my vertex, x equals -4. Remember, it's the line that cuts it in half. Okay, domain, -infinity to infinity, because if I keep drawing this forever, it's going to get wider and wider and wider. Now range, it goes down forever, and the highest point is at 1. Okay, this has a maximum but no minimum because it goes down forever. So it's -4, 1. Remember, your x-intercepts are where y equals 0. Here, I know it says vertex and y-intercept twice, I'm sorry. Okay, so let's type this one, x minus 4 squared minus 4. Okay, so let's find there's my rainbow. My vertex is in the middle, so 4, -4. Y-intercept is where x equals 0, so 0, -20. x-intercepts are where y equals 0. Well, I don't see y equals 0, so let's graph it. If you see, it never touches the x-axis, so there's none. Axis of symmetry is x equals the x of my vertex. Domain, it goes negative infinity to infinity. Range is your height. It goes down forever, so negative infinity. All the way up to what? How high is that? So that's going to be negative 4, because that's, remember, part of your vertex. Okay, now does this have a maximum or a minimum? It's got a highest point, so it's a maximum, no minimum. And it's just my vertex for negative 4. Okay, so again, another one. So 2x squared minus 8, second graph. Here's my rainbow. So my vertex is in the middle, 0, negative 8. My y-intercept is where x equals 0, which is also my vertex, which doesn't always happen, just sometimes. X-intercepts are where y is 0, so negative 2, 0, and 2, 0. Axis of symmetry is x equals the x of my vertex. Domain is negative infinity to infinity. Range, so this is where it gets a little weird. So we're going to look at it. The lowest it goes was negative 8, and it goes up forever. No maximum, but it has a minimum at 0, negative 8. So now I'm given a table, but it doesn't give me all my points. Like, I don't see my vertex, I don't see any of that. So that's when we go to stat and we type in our points. What did I do? 8, 7, 5, 3, negative 2, negative 1, 0, 45, 24, 0, 0, 9, 24, 45. Okay, so second, oh, sorry, I don't know what I'm doing. Stat, calculate quadratic, because that's what we're dealing with, is quadratics. And here's my equation. So a standard form equation is y equals 3x squared plus 24x plus 45. I'm going to type that in my y equals and find my whole graph. Or table, sorry. So find my rainbow, there it is. Okay, I thought I added something on accident. Okay, my vertex is in the middle of that. So negative 4, negative 3. My y-intercept is where x is 0. So 0, 45. X-intercepts are where y is 0. So negative 5, 0, negative 3, 0. Now, these are what my rainbow tell me. So negative 6, negative 9 rainbows to negative 2, 9. Negative 124 rainbows to negative 724. Axis of symmetry is x of the vertex. If I hit graph, this opens upward, and we already came up with the equation. Guys, I really honestly believe that the table is the easiest way to find all of this. Now these, you can do these in your calculator, but I'm going to do them with the IHOD over rules. IHOD over, which is on the wall, and you can use it. Okay, so from here to here, this is just the parent function. So the negative is on the outside, so it's vertical. So this reflects vertically, which is over the x-axis. And the plus 6 on the inside, remember this is opposite, so it's going to be left 6. Now, multiplying means compression or expansion. So this means a vertical compression because it's smaller than 1. And minus 4 on the inside is horizontal, so right 4. Vertical expansion because it's got a number bigger than 1 being multiplied to x. and a plus 3 on the outside, so it's vertical, and it goes up 3. Now, you could have also typed all of these in your calculator and compared them that way to see these changes. Okay? Calculator, calculator, calculator. Okay, let's look at number 9. So this is talking about the parent function. I know it's x squared, so I'm going to find my rainbow. Here it is. I'm going to graph it. So 0, 0, 1, 1, 2, 4, 3, 9. Okay, my vertex is in the middle, which is 0, 0. Equation of the axis of symmetry is x equals 0, because that's the x of my vertex. This is going to get wider forever and ever. It does go from 0 to infinity, and it actually touches 0, so that's a bracket. My x-intercept is 0, 0. My y-intercept is 0, 0, because that's the only place we have x and y are zeros. Okay, pretty simple. So it says circle the correct description of the following function. So let's graph it. Negative x squared minus 2x plus 1. Second graph. So it's opened downwards. Now we could have figured that out just by knowing that a is negative. Or you looked at the graph, and your y-intercept is where x equals 0, so it's 0, 1. Now it says compare these following graphs, so let's type them in. X squared minus 10x plus 20, and then x minus 5 squared minus 3. Second graph, sorry. Now, are these exactly the same, or are they different? They're different. How do we know? We looked at our graph. Okay. Vertexes are different. How do we know? We looked at our graph. Okay, shape and size. Technically, these have the same shape and size, and this is more of an equation thing. Neither of them are wider than the other. One's just shifted up because this is technically 1, and this is technically 1. So we know that they're the same because both have a equals 1. The y-intercepts, we can go to their tables. That's where x equals 0. This is at 20 and this is at 22, so those are different. So we can say we looked at our table. Axis of symmetry. So if I were to cut this in half, I'm going to cut them both in half at the same spot, so they're the same. And they both open upwards, so that's the same. And we looked at our graph. Okay. Now it says graph the following equations, then list the letters of the graphs in order from smallest a to the largest a. So I'm going to sketch them. So I have 6x plus 3 squared plus 1. Oops, sorry. So it's this, and it's pretty skinny. Okay. 1/3 x squared. Oop. Dang it. 1/3 x squared plus 1. Graph. So this is pretty wide. Okay, then we have x squared minus 5, which is average. And then we have 2x squared, which is a little skinnier. Okay, now I want you to realize the a here is 6, the a here is 1/3, the a here is 1, and the a here is 2. So which one has the smallest a is the widest? And the largest a is the skinniest, because remember, it grows faster. The bigger the a, the faster it grows. So my smallest a is B, then C, then D, then A. So that's from widest to skinniest. Describe this function. So I'm going to go ahead and draw lines. And I'm also going to sketch the parent function. Guys, just a sketch. We drew it up top. Okay. Describe the transformations. Well, first off, we realize it reflected over x-axis. Then from vertex to vertex, it went up 1, 2, 3, 4. And then left 1, 2. And there we go. Now, I know this cutoff, I'm sorry, for this. And then it goes even further. Whoa. Okay, we did this one in class, so I'm not too worried. It touches here. This is at 2, this is at 0, because it's counting by 0.2, 0.4, 0.6, 0.8, 1, 0.2, 1.4, 1.6, 1.82. So the domain is from 0 to 2, because that's the width. Now, why is this not infinity, negative infinity to infinity? Because we have a situation. We're kicking a soccer ball. Do we kick a soccer ball and it goes forever? No way. Okay? Nobody's strong enough to do that. Okay? So it goes from 0 when we started all the way till 2 seconds when it was done. Now, range is my height. So from 0 to 16. And brackets because it touches those points. What's the maximum height? Is here, which is 16 feet. Now at 15. The graph below shows the height of a baseball from time it is thrown from a top of a building to the time it hits the ground. When does the baseball reach its highest point? So when, we're looking for time. So here, so that would be 4 seconds. How long has the ball been in the air when it hits the ground? Well, this is time, so that's 9 seconds. How tall is the building from which the ball is thrown? If you notice, the ball didn't start on the ground. It started about here, so we'll say about 45. If you wrote anything really between like 43 and 48, I'll take it. Just realizing it's between 40 and 50. Okay, how can we tell from the graph that the ball was thrown and not dropped? Well, think about it. If you just drop something, it goes down. It doesn't go up. Like this went back up, then down. So it went up first. That's how we know it was thrown and not dropped. What would be a reasonable domain? That's from the width, so it started here and ended here, so from 0 to 9. And a reasonable range. Yes, it started way up here, but it went all the way to the ground. So it went the lowest to 0. The highest we'll say about 126. So it looks like a little over half. If you wrote anything really between 122 and 129, I'll take it. Okay, so that's that one. Here, guys, this is calculator. You're given equations. Let's type them in. Negative x minus 3 squared plus 4. Second graph, I'm looking for my vertex. So I need to find my rainbow, which is here. So 3, 4. This is the only one with 3, 4. So this is A. X plus 3 squared minus 6. Finding my rainbow, which is here. Negative 3, negative 6. So that is here. So this is B. X squared plus 4x plus 4. Second graph. Let's make sure I did it right. And here's my vertex, which is negative 2, 0, which is here. So I did do it right. A quadratic inequality is shown. Okay, remember dashed lines do not hold solutions. Solid lines and shaded areas hold solutions. So my only solutions are in here. Okay, so for a y value of 3, I want you to realize that a y value, y is your height. So at a height of 3, find 2 corresponding and 2 non-corresponding. So remember, corresponding means solutions. What x's make that a solution? So all of these 3 in here. So it doesn't matter which ones you pick. I'm going to pick 2 and 3, or 2 and 4, or 3 and 4, whichever way you wanted to do it. And non-corresponding would be anything out here. So we'll say like negative 9, and what, like 5? Could I have picked a number on the dotted line? Yes, but they didn't have pretty points, so I didn't do that. Because remember, dashed lines do not hold solutions. Now it says for the graph at the right, what type of inequality sign would we use? Well, we know that these are my options. I would not use these two because that would be a solid line. Now remember, vertex above my vertex, above you is greater, so we would have used the greater than symbol. Here we're going to find the quadratic. Now on this one we have to do all the points because it's looking for stat regression. So 20, 40, 60, 80, 100, 140, 160, 180, 200, 25, 40, 55, 65, 71, 77, 77, 75, 71, 64. So then remember we do stat, right, quadratic regression, enter, 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 enter. There's my regression. Now it says to the thousands place, which is 3 numbers. So negative 0.004x squared. Remember I rounded because 7 makes that a 4. Plus 1.032 because the 8 makes that a 2x. Plus 5.667 because the 6 makes that a 7. There's your answer. Now if I were to graph this, if you see I don't even see anything because these numbers are huge. Don't worry about graphing it. 21. I don't even want you to use a calculator. Technically you could. You could plot all these in your calculator and you would cross these out because those are open downwards. Remember, I hot over, inside to the left, plus 2 is to the left. Did this move to the left 2? No. This went up 2, which is outside plus, so this is D. Again, you could have typed this in your calculator to find your answer. Last but not least, this is a problem to make you realize that the rainbow helps you. -3, -3, these are all counting by 1, that's why this works. Okay, so if those match, then this has to match that, and this has to match that. So now we have all of our points. So what is the y-intercept? That's where x equals 0. So 0, -3. X-intercepts are where y equals 0. So we have -1, 0, and 3, 0. Axis of symmetry, let's find our vertex first. So vertex is in the middle of our rainbow. Remember, it's always the x of your vertex, so x equals 1. There we go. Guys, this should be an easy test. If you'll have any questions, bring them to me at the beginning of class tomorrow. I will be more than willing to help you. Just make sure you're on time and ready to go. Good luck. Y'all will do great.